Welcome to Submodule F of the Copernicus Land Monitoring Service, which in this case deals with a very practical application of the high-resolution forest layer product, which is a component of the continental land monitoring service. It deals with assessing and estimating grassland harvest in Bavaria, which is in southern Germany, which is a study implemented to assess the feasibility of doing such assessment with the help of radar data and Copernicus products. As background, one should say that grassland in southern Germany is one of the most important sources of protein, which is used basically for producing milk and meat, indirectly by feeding hay. And it's also one of the most important sources for biogas production. So grassland is a very important agricultural product in southern Germany, and even slight changes in the amount of grassland harvested can have relatively high impacts on the market and on the prices. So this is important to know relatively exactly how much grassland is produced per season. So there's political and also industrial entities having information needs in that respect. Specifically, there's information gaps with respect to the grassland harvest per season and the related productivity of the grassland areas. And there's specifically a gap because such harvests are not really measured. So there's no measuring or gauging system. There is no weighing. There is no reporting of these things. So farmers just harvest and sell their grassland or use their grass and hay themselves, but there's no systematic capturing of the amounts. So this is where Copernicus and radar remote sensing comes into play. There's been a use case created, basically triggered by the Bavarian Agricultural Administration, who's interested in knowing the number of grassland harvests per season in a spatially explicit manner. And there's the need to improve the model for grassland productivity that is currently used by such administrations. And this needs to be fed with really tangible data, which are measured either on the ground or by remote sensing data. So if you look at the graphics on the right, this is a schematic presentation how grassland productivity is going over time. So this is the amount of grassland yield in terms of harvest. So you see at the beginning of the season, the biomass is accumulating, then you have the first harvest, biomass is again accumulating, second harvest, and so on. That can reach 3 to 4 harvests per season in southern Germany. This specific case study has been implemented by the State Entity for Agricultural Research, which provided information on the test areas, on the on-ground verification and validation of the biomasses which occurred there, together with the University of Kiel, which provided the modeling expertise for modeling the grassland productivity, and together with some specialized service providers who provided the radar evaluation expertise for the related remote sensing data. So in terms of the data that have been used for this study, the input data are twofold. On the one hand, it's Copernicus data, comprising grassland areas as provided through the high-resolution grassland layer. For that study, the current high-resolution layer 2012 has been used. The current situation is such that a further one is upcoming, is being produced for the reference year 2015, which provides even increased capabilities and better specifications, so which is expected to further improve such biomass assessments. And there may be also other sources on a subnational, regional, administrative level on grassland, which all can be used for that purpose. On the other hand, there are satellite data provided by Copernicus, specifically the Sentinel-1 data, which is a radar satellite, which provides regular radar-based observation of the Earth's surface. And this can be used to estimate the harvest time and the harvest quantity also. Beyond that Copernicus data, there is information available from the IX, the Integrated Administrative and Control System, which is basically an administrative control system used on a European level for farms and fields to record the agricultural information that's used for European Union subsidies and also for targeting and for following up on environmental measures that are applicable on specific fields. So the demonstration will basically show how that harvest date assessment is done. It will present the results of the grassland productivity modeling and show some practical graphics and overview results, how you have to imagine such results and what to do with those. In terms of change detection using radar data, there's principally two possible things that can be done with the existing sensors that are currently in orbit. First opportunity or first option is to use pairs of images of basically the same sensor in a time series approach. So for example, there's satellites, constellations up in orbit which are operationally running with several satellites which provide the opportunity to have acquisitions every few days with the same geometry. That should be also possible with the Sentinel-1 constellation. And that provides the opportunity to monitor with the exactly same geometry, the same areas, the same fields in a regular interval. The second option would be to use a multi-sensor approach, so combining time series of several radar sensors. So that means commercial or semi-commercial sensors together with Copernicus sensors and other freely available sources to increase that update cycle and that data availability cycle to even up to 1 day. So that is the two options. And regardless which one you do, the administrations would have two scenarios which they would be interested in, even with the denser time series or the less dense time series. What they want is either to have an annual reporting of how much has been harvested in a certain region, in a certain area, on certain fields, or to have a monthly reporting, basically to have regular updates to monitor during the season what's happening. I'll just show you the workflow of how that assessment is being done and show you also some results. So this rather cryptic workflow shows basically nothing else but that there is radar remote sensing data used in a stack of a time series. Can be Sentinel data, can be other data. Of course, they need to be brought to a common geometry. So we have to have steps of co-registration between these images, and they need to be also calibrated, and they may also need to be geocoded using information from a digital elevation model so as to have absolute correct geometries fitting to the ground information. And you have, on the other hand, you have various input data which are used, as I mentioned, the IX data, which provide the on-site information. You have Copernicus data like from the high-resolution grassland layer. You have probably also further in situ data, reference data that are available from farmers or from administrations, which can all be combined with the time series of the satellite observations in various filter operations or in temporal ratio operators, which provide basically a measure of the changes that do occur over time, considering the specific properties of agricultural fields and also considering the confines of the agricultural fields. So what comes out is then basically an assessment of the changes that do happen in these agricultural fields over time. And this information can be used to be fed into maps, reports, online services, whatsoever. So if you look at the example shown here on the screen, you have the agricultural parcels as indicated by the yellow outlines. So these are basically field boundaries relating to agricultural parcels. And when we go through the time series, you see that this is the time frame from 1st of May to 9th of May. You see radar information available in these boxes or polygons of fields. And if you now apply a classification or a thresholding approach to that radar-based information, which you see has different gray tones, which is a different reflection intensity of radar data, then you can do a thresholding and identify really the changed areas which are indicated in blue here for that time frame. And you can continue that, having more of these time frames, like 2nd of May to 10th of May, so which is partially overlapping from a different sensor. And you see that also in this time frame, you have detection of changed areas And so you can continue for other time frames, and in each time frame you can do a detection of the changed areas. When you combine this information on the changes that are captured by radar data, so you get the harvesting and the mowing dates, together with further information that you can get from either meteorological information, like station measurements, like how much precipitation is recorded, which amount of solar irradiation is recorded, because that's important for the plant growth. If you combine that into models, together probably with further information from meteorological satellites, and you add further information that is available on a field level from farmers, from administration, you can really feed all this into a geographic information system, combine it with the harvest date assessments, put it into a harvest model that models in a continuous manner the growth and harvest of grasslands in certain fields. Then you can get to an integrated grassland harvest assessment. And what that means practically in the end is shown on the last slide here, where you see in an integrated fashion the changes that have happened in certain time steps. So the yellow fields are in the first 2 days of May 2015. The greenish one are in the next week of May. And so it continues, and you see that you have all these shades of different harvest dates. And there's probably also some unknown dates which cannot be determined exactly by the data that are available. But you see that with this kind of assessment, you can get to rather precise estimation of when what happens in the grassland areas. Thanks for your attention. Hope to see you in the next module.